Yo, what's up, calculus students? Let's get into unit 7 review and then lesson 10.3, volumes of solids with known cross section, placing objects on top of regions. But got a big unit 7 review to do. And I told half of the students this. Well, the students I think we all did this during class, but I'm gonna do this anyways. It makes it easier if you are given an initial position. Cool. We have two particles. One, the position's given. X of B is the position on the x-axis. The other one, the acceleration's given. Just remember, P prime, P double prime is like a position of velocity and acceleration. So that means V prime is A. So if you took the derivative and if you said P of T is equal to X of T, these problems, typically you need position, velocity, acceleration, the position, the rate of change of the position and the rate of change of the rate of change. You'll be able to then just use these equations over and over again. So there's my velocity. Here's my acceleration. If we went backwards, we have to take the antiderivative. So V of A, how do you take the antiderivative of 12? It's 12t plus c. V of 0 equals negative 12. So that means V of A is 12t minus 12. And then my position of A, which you can consider x of A of t, is going to be 6t squared minus 12t plus c, but c is going to be 1. So I'm just going to replace this with 1. All these questions can be answered by understanding what to look for with your equations. So here we go. Are they moving toward or away from each other at t equals 2? I need the position of both particles at 2. And I need the velocities of both particles at 2. P of A at 2 is 24 minus is 1. P of B at 2 is going to be negative 16 plus 12 plus 24. So that's 36, 20. Cool. Velocity of particle A at 2 is going to be 12. Velocity of particle B at 2 is going to be negative 24 plus 12 is 0. All right, well, so that's cool. So that makes it easier to answer. Particle A is to the left of particle B, moving to the right. Particle A's position is increasing. Particle B is positioned at 20 and it's not moving, so towards each other based on the positions and velocities. What is the position of particle B furthest right? We need to do a velocity sign analysis, P prime analysis, first derivative analysis to figure out how P is changing. P prime is V, particle B, V of particle B is this guy. So V of B, gonna factor out a negative 6, so that equal to 0. Starting from 0 to 3, you can see the only one I have is at 2. I have this negative 1, but I don't have to put it down. Use some test points like 2.5, positive, positive, negative. Could use a test point like 1, negative, negative, positive. Cool. So my position is increasing, then decreasing. I can tell this has to be the max, but I got to justify it. So I'd say t equals 2, or I could just say p of 2, which equals, I found p b of 2, which equals 20 is the max because velocity is positive from 0 to 2. Velocity is negative from 2 to 3. What is particle A furthest right? Let's go to particle A's velocity, 12t minus 12. And then we got particle A's position. So setting that equal to 0, you get t equals 1. So we'll do our sign analysis of the derivative. We'll have negatives and positives, which means my position decreases, then increases. It means I have two possible locations for max. So max is either at t equals 0 or t equals 3, because my velocity is negative from 0 to 1. My velocity is positive from 1 to 3. P of 0 is, this is particle A, 1. P of 3 is 54 minus 36, which is 18 plus 1, which is 19. Max position. Find the average position of particle A. Well, to find the average of something, I need to accumulate that something and then divide it by the interval. Without a calculator, I'm going to need super P. A lot of people like to accumulate by velocity. If you accumulate your velocity, you do get a change in position. But if you accumulate velocity and then divide it by the time interval, you'll get an average velocity. It becomes like an average rate of change of position, which is an average velocity. So we need position of particle A, which is 6t squared minus 12t plus 1. Which means super P of A of t is 2t cubed minus 6t squared plus t plus c. Super P of A at 3 would be 2 times 3 cubed minus 6 times 3 squared plus 3 plus c. But when you subtract super P of A of 0, you're just going to get super P of A of 3 without a c. This would be your answer for the average position. When is the velocity decreasing? Okay, a velocity will decrease when its derivative is negative. I need to look at the acceleration for particle B. The acceleration for particle B is negative 12t plus 6. I'm going to see when that equals 0. That's going to be when t equals positive a half. So my A, which is V prime, will tell me about V. If I plug in 0, I get a positive. If I plug in something greater than a half, I'll get a negative. My velocity is increasing then decreasing. So my velocity will be decreasing for all times greater than 1/2. My justification is that V prime, which equals A, is negative. Speed decreasing. I need to do a first and a second derivative sign analysis. We're looking for when velocity values are getting closer to 0. That's when we will be slowing down. That's whether we have positive velocities that are decreasing or negative velocities are increasing. Signs of V and A are the same. So I got 12t minus 12 and 12. That's easy. Great. So my V is 12t minus 12. My A is 12. So that means my velocity is always increasing because the acceleration is positive. My position my velocity is always increasing. My velocity is positive until 1. Now it's negative until 1. It's positive after 1 if I plug in values. That means my position is decreasing or increasing. But really for speed, you're looking at velocities getting closer to 0. When your velocity is negative and increasing, or when your velocity is negative and your acceleration is positive. So from 0 to 1 is my answer. My justification is V and A have opposite signs. It's the easiest justification. You could say your velocity is negative and increasing from that interval. Distance traveled by particle A. Well, guys, what we need to do is understand that I would love to accumulate the absolute value of V, but I can't do that without a calculator. What I have to do is really understand how is the particle moving. We look at the velocity of particle A, which we have right here, which is negative until 1 and positive after 1. Which means your position increases, then decreases. Your goal is to actually figure out how much it increases, how much it's decreasing, or find your displacements, like accumulate your velocity. You need your position at time 0, your position at time 1, and your position at time 2. And then you'll be able to tell how your position's changing, your displacements. You'll be able to tell, like, the distance traveled. So particle A, its position at time 0 was 1. At 1, it'll be negative 6 plus 1, which is negative 5. Then I found it at 2. Particle A at 2 was also 1. Oh, great. Yeah. No. Yeah. 24 minus 24 plus 1 was also 1. So cool. So that's also 1. So what's the distance? Hopefully you realize this doesn't make any sense. What am I doing? This makes sense. I'm just being silly. My position decreases, then my position increases. How much does it decrease? If you accumulated your velocity, it would decrease 6. How much would it increase? It would increase 6. The distance is 12. I did P of 1 minus P of 0, absolute value. Or I took the opposite of my integral from 0 to 1. Then I added my integral from 1 to 2. Honestly, if you just have this down, and if you just show like P of 1 minus P of 0 equals negative 6, like if you have that work down and you show your displacements, like, you're great. All right, the other type of question was a Desmos question. It's when you're given the equation of the velocity and you do all your work. So we're going to graph our velocity. We're going to graph it over an interval. I'm so happy to be outside right now. Like, this is the weather I think I love the best. Warm sun, cool breeze. I can sit in the sun. Go from 0 to 8. I'm literally type it in just like you see it. Okay, there's my velocity. Particle is at a position of 4 when t equals 8. All right, that's important to write it correctly. The position at 8 is 4. We can see your derivative, your velocity, is positive until this value. I'm going to store this value. Oh, pi. And negative until 2 pi. That makes sense. Cool. I mean, that's easy to do. So we could say A equals pi, B equals 2 pi. We can see it's positive until A. It is negative until B. It's positive after B till 8. All right. Yeah. So we can tell that my position is going to be increasing, decreasing, increasing, which means I'm moving right, moving left, moving right. Furthest left is either at B or at 0. We're looking at the min position. So if I go up, then down, then up, I know this can't be the min. I know this can't be the min. The mins could be 0 or B. My justification is that my velocity is positive from 0 to A and B to 8. And my velocity is negative from A to B. Make sure you have all of your intervals all written down and you're good. So I have to find my two positions. My position at 0 will equal my position at 8. Then either you can add your accumulation from 0 to 8, or you can subtract your accumulation from 0 to 8. Remember, like, we got to go backwards. So if you accumulate velocity, I should have saved this. Oh, whatever, I'll type in pi. Like this accumulation of 8.91 tells me I go to the right 8.9. If I want to go backwards, I need to subtract. If I go all the way to 8, that means I ended 6.092 to the right of where I started. So that means I will take my position at time 8 of 4 and subtract that to get 2.092 is where I started. Am I on like super computer mode? On slow computer mode, it looks like. Power mode. I need super performance. Go. Okay. All right, so this is negative 2.092. I think that's going to win because you can kind of see this accumulation is going to be bigger than this accumulation, which means I move to the right a lot, then move to the left a little bit less. If I went and checked out 2 pi, of B equals P of 8 minus B to 8. Should go from B to 8. Screwing up here. That's probably something you guys haven't done much. 1.773. Let's say you weren't comfortable with that. Let's go back to going to find your position at 0. You could then take this position at 0 and you could have added your integral from 0 to 2 pi, your velocity, to get the same answer in that 1.773. It's probably tough to think about going backwards just a little bit. So maybe go all the way backwards and then just start over. Once you have your position at your start, you can go from there. 1.773. So this is my answer. This is my min position. When is the particle speeding up? You can immediately justify V and A have same signs. This is when your velocity is going to get further away from 0. So you can see your velocity is getting further away from 0 to 0 to this value, which is the max. So 0 to 1.287. And then from here to here, pi to 4.593. And then also from 2 pi to 7.778. And obviously you can replace this with A and replace this with B. So V and A have the same signs, or we're talking about velocity getting further away from zero. Probably would have added another one. What is the distance traveled from 0 to 8? And just remember, you want to accumulate all of your speeds. So all of these accumulations as positives. So you want, you can go shift and then the dash, the backslash. Is that a backslash or a forward slash? Shift backslash, that works. 16.187. All right, now we get to the lesson. You don't understand why we're doing what we're doing? Watch the lesson. We are taking objects, replacing it on the region. Apparently, I'm not allowed to use Desmos here. They are putting objects that are coming out of our paper. We need to find the volume of it. It's actually going to be a simple idea. It's like, okay, if I am placing something perpendicular to x-axis, first thing is perpendicular to x-axis. You know that there's a square coming out. Well, cool. Well, we have a height and a width of that rectangle. That rectangle then has this third dimension, which is another height. Because it's a square, this and this are the same. So what we could do is like h dx h or h squared. In this case, just my height squared gives you the areas of the regions times dx. We're good. So if h is root x, h squared is x. I want to sum up my h squareds from 0 to 4. If I do that, I'll sum up my x's from 0 to 4. To do this without a calculator, you need super h squared. Maybe you could say this is your area. I'm trying to figure out the best way to do this without a calculator. And then super A is going to be 1fx squared. Let's see. So super A of 4 minus super A of 0. You can think about it as a super h squared, but I'm kind of worried about that. So we'll have 8 is the answer. Could have immediately just gone here and then be like, oh, I need that. We use this line as like, oh, I'm going to take the antiderivative. I did, and then plug in 4 and 0 and subtract them. 4 squared, 16 divided by 2. Yep, good. And then we talked about how, like, that's the lesson. Like, any other object is kind of a basis besides semicircle is the basis of that. If I said, oh, isosceles right triangles, well, all you're going to do is take this and divide it by 2. Isosceles right triangles will be 1/2 h squared. So I just need to do 1/2 h squared from 0 to 4, or I end up with the answer of 4. This 1/2 can come out. I would have super h squared of 4 minus super h squared of 0. I'm not sure if that's good. Yeah, I don't know. Super h squared is going to be equal to 1/2 x squared. I kind of like that. Whatever. So yeah, it's 1/2. That's tough. H squared is a. You figure out what way makes sense to you if you're to do it without a calculator. Okay? I don't know which way is the best way to understand. Okay. Now we're going to go perpendicular to the y-axis. Not going to use my calculator. Now this is going to be tough. And now I'm going to try to do my best to understand it. Well, that rectangle has a width. The width is an x equals 4 minus an x equals y squared. Cool? I'd sum these up from a y equals 0 to a y equals 2. If I put a rectangle here whose height is half the base, well, the base is w, the height is 1/2 w. That means I'll have 1/2 w squareds. So if like this comes out like that, this is going to be a half w. So I want a 1/2 w squared. I want to sum up those 1/2 w squareds. The height of the rectangle is a small y distance. So I want to sum up 1/2 w squared times dy from 0 to 2. Now, if w is that, w squared is 4 minus y squared squared. W squared is 16 minus 8y squared plus y to the 4th. You can consider that your area or something. That's not because you need the 1/2. You could just put this inside your integral. I have to simplify like that because I need to take the antiderivative. I can't take the antiderivative of that. I have to distribute so that I can take the antiderivative of that and have super W or super A, super W squared. So I'll have a half times 16 times 2 minus 8/3 times 2 cubed plus 1/5 2 to the 5th. Minus 0, but when I plug in 0, I get 0. Now we have the fun semicircles. This without a calculator is going to be tough, but hopefully you'll understand what I'm about to do. Well, the radius is going to be w divided by 2. That's 4 minus w squared over 2, which is 2 minus a half of w squared. That's going to be very important to do. That we want to have pi r squared, but that's pi w over 2 squared. So I want to sum up from 0 to 2. Half of those, because it's a semicircle, half of pi w over 2 squared. Well, w over 2 is that. Now, if I were to take the antiderivative, I can't take the antiderivative of w over 2 squared like this. This is not an antiderivative I can do, even with u substitution. So I have to distribute everything. And this is where it's tough. I'll get 2y squareds after I distribute everything, and then place y squared over 4. If you need to, when in doubt, write it out. Hopefully you know like 2 times 2 is 4. I'll have negative y squared. I'll have another negative y squared, so I have 2, and then I multiply them together. Which is why I'll have a pi over 2, and then I'll take the antiderivative of this. You can call this a. You can say super a is 4y minus 2/3 y cubed. And this is y cubed over 12. And you would have super a of 2 minus super a of 0. You'd have 4 times 2 minus 2/3 2 cubed plus 1/12 2 This is a fourth. Should be a fifth of 20. Two to the fifth. Then minus 0 because of the super A at 0. Okay, so that's tricky, obviously. I'm going to go ahead and just use Desmos and double check all my answers because the Desmos portion is done. Oh boy. Hope this video is being taken right now. This is bad, guys. Okay. There we go. Bam, 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 bam. All right, first question. Heights are X. Well, H was screw X. I wanted to integrate from 0 to 4. My height squared. And I got 8. Okay, I got that as well. And then if I put a 1/2 in front of it, obviously I have 4. So first two questions are correct. 8 and 4. Next question got harder. I had widths that were 4 minus y squared. And I summed up from 0 to 2 my width squared times a half times dy. I got 8.533. I thought that without a calculator, the answer would be this. Bam. Cool. Then I had these semicircles, and the semicircles were 1/2 a pi. It wasn't w, rather w over 2 squared. If you're going to use w or w of y, just make sure you use w and w of y. Like, keep things consistent in Desmos. And I got that answer, 6.07. And I thought that's equivalent to pi over 2, 4 times 2 minus 2/3, 2 cubed, plus 1/20th, 2 to the 5th, and wouldn't you know it? Okay. All right, the rest are going to be easy, so long as you understand what's going on. We're going perpendicular to x-axis. I got to figure out when these two things intersect. Let's say we use Desmos. Am I using Desmos now? Yeah, I mean, let's go ahead and use Desmos. I'll show you how to do it without, but go ahead and use Desmos. All right, so when does x squared equal 2x? That's when x equals 2. You could also subtract and factor and solve. So 0 and 2, which would mean this will be 4. All right, so these are heights. Widths are small x. We got rectangles. Height is going to be 3 times the base, so that's going to be 3h. H is a y equals top minus a y equals bottom. So h equals 2x minus x squared. And I want to sum up my rectangles area, which is 3h squared times dx. And if I wanted to do this without a calculator, it'd be tough. h squared would be 4x squared minus 4x cubed plus x to the fourth. So that means super would be this. So this is equal to 3 times 4/3 2 cubed minus 2 to the fourth minus 1/5 2 to the fifth. But I'm cool with this, guys. That's great. I'll show you how they're the same. My height was 2x minus x squared. I got 3, 0 to 2, h squareds. And I think that's equivalent to 3 times 4/3 2 cubed minus 2 to the fourth minus 1/5 to the fifth. Uh-oh. 3h squared, 2x minus x squared. That's top minus bottom. Square it. 2x times 2x is 4x squared. Negative x squared times negative x squared is positive x to the fourth. Of negative 2x cubed and another negative 2x cubed. Okay, so that's 4/3. This is x to the fourth. Oh, there's a minus. And this is a plus. Bam. Great if you got that. If you get this, even better. Perpendicular to the y-axis squares. All right, so perpendicular to the y-axis, I now have a very long width. We have squares who are going to also have this w. So it's going to be w squared, summing up w squared times dw is the skinny height of this. Dy, which is the skinny height of this. W is x equals root y, and x equals y over 2. We'll sum them up from a y equals bottom to a y equals top. This will be my answer. W equals squirt y minus y over 2. And if I want to integrate w, it'd have to be times dy. And I'm going to go from 0 to 4. Okay, great. How would I get that answer differently? I would need to figure out what w squared was, and I would need to anti-derive that. So root y times root y is y. Root y times negative y over 2. This is going to be minus y to the 3/2 over 2. So it'll be minus 2 of those. And then y over 2 times y over 2 is going to be y squared over 4. We'll call this like a. Super A would be 1/2 y squared minus y to the 5/2 times 2/5. Plus this is y cubed over 12. So this answer, which I got, 1.333, is 1/2 4 squared minus 2/5 4 to the 5/2 plus 4 cubed over 12. Let's see. Nope, something happened. Was it a plus that I messed up with? No, I got that. Y 3/2 over 2. Okay, that's good. Twice. And then y squared over 4. That's good. antiderivative of y cubed over 12. Good. Y to the 5/2 times 2/5. That's good. Y squared over 2. That's good. Plugging in 4. Yes. Shoot. All right. So there you go. There's your answer two different ways. Using your calculator, sum up your W squareds. You got it. Yeah, definitely using decimals. I'm not going to do this. So semicircle's area is a half pi r squared. R squared is going to be my h over 2. Since I am back to being perpendicular to the x-axis, I don't want to do this without a calculator, so I'm not going to. Height is 2x minus x squared. If I divided by 2, I'd have x minus x squared over 2. But instead, I'm just going to sum up from 0 to 2 my 1/2 pi h over 2 squareds. Cool. Self h. So here we go. 1/2 pi h over 2 squared. What's going on? dx. There you go. 13.4 over 13.4404. If you were to do this with a calculator, you should probably write what h over 2 is. H over 2 would be x minus x squared over 2. And then you would need h over 2 squared, which is x squared minus an x cubed plus x to the 4th over 4. And then you would need the antiderivative of that. Maybe you just write it like that. 1/3 x cubed minus 1/4 x to the 4th plus x to the 5th over 20 plus c. So your answer is going to be 1/2 pi times 1/3 2 cubed minus 1/4 2 to the 4th plus 2 to the 5th over 20. Plug this in, you're going to get 13.4. All right, Desmos. Perpendicular x-axis. Semicircles. Here's perpendicular x-axis. There's a height. My height is going to be my top minus my bottom, y equals y equals. Cool. Semicircle is 1/2 pi r squared, but r is h over 2, so it's 1/2 pi h over 2 squared. Easy to type in. I need to sum these up from a to a b. This will be c and d. So let's go ahead and find some intersections. So I got y equals 2x plus 1. Got y equals e to the x over 2. I got this intersection, 0, 1. This intersection, 6, 7, 3, 3, and that. I'm going to save that, cut, paste as D. Save this as B. I know C is 1. So, semicircles, I need to sum up from 0 to B. My 1/2 pi r squareds, my r is h over 2. There's h times their skinny width. Don't forget, this small width of this rectangle is a small x distance. It's like nothing. So I have an integral of h. H is 2x plus 1 minus e to the x over 2. Integral from 0 to b. My 1/2 pi h over 2 squared. 6.215. Perpendicular to the y-axis, squares. Squares will have a width. The width is this x distance. It's got a small height, dy. It's x distance. I need to solve my equations. For x, y minus 1 over 2 is x log y times 2. Don't forget, if you have y equals e to the x over 2, you should take the natural log of both sides and then multiply by 2. 2 log y equals x. My width is x equals right minus x equals left. I need to sum up my widths squared. If this is my width, this is my width. My width squared times dy, it's skinny height for 3 dimensions. I'm going to go from 1 to d. Write down what w is. W is right, which is 2 log y, minus left, y minus 1 over 2. Use parentheses, do something like that. I don't want to look at h. I don't want to look at w. Just want to look at that. 7.913. Rectangles whose height is always 4 units. So that means like our rectangles, the height's always going to be 4. So that means this area has this height times 4. So this is 4h. So I just need to sum up from 0 to b 4h. Perpendicular to the y-axis. Oh, geez, my bad. I'll make something up. So this just needs to change to be 4h. $31.27. Why don't we do semicircles? Want to sum up from 1 to b, 1/2 of my pi r, which is w over 2 squared. dy is the height, so 1/2 pi w over 2 squared. 3.107. Perpendicular to the x-axis squares. Do you need 2 separate integrals? Well, let's think about it. If this is y equals log x and this is y equals 5 minus x, if I start accumulating these vertical guys, yeah, I need 2 integrals because we start changing what the heights are. The answer is yes. I need my h1, which is log x, and then I need my h2, which is 5 minus x, minus 0. I need to figure out the intersection between these two things. .693, I'll call that A. This I'll call B. This intersection. It's good to check. Too, like you get the area 2 different ways. So I need from 0 to A, my h1 squared times its skinny height. skinny width. The width is a small dx. And then from A to, this is 5. Need my h2 squared. I had too much stuff going on. Integral. We call this h1. It's h2. From 0 to a, h1 dx, plus integral from a to 5, h2. This would be the area. This is equivalent to the sum up of my widths. It's a good practice here. If I flip these on the sides, my width, x equals, add x, subtract 5. X equals right minus x equals left. If I sum these up from If I sum these up from 0 to b, I should get the same answer. I don't. Why not? 5 minus y minus e to the y. From 0 to b. What's going on? I'm totally getting something done right now. Yo, I'm tripping right now. Oh, because it's not 0 to a. Gosh, darn it. Mr. Messner. 1 to a. Yeah, okay. So we got the same answers, but now we should have gotten the same answers. Now we just want to square. All right, so this is perpendicular x-axis squared would be these. $2.784. Silly. The answer is no. I just need from 0 to b my width squared. Ends up being different values. That's okay. 8.522. You end up, it's tough to see, but the objects will be different based on the shapes. The shapes will look different. They'll look similar, but they'll be different. All right. All right, good stuff. Good review and then good problems. Peace.